Hello, so we're going to have a look at some further um, calculations using speed as distance over time. So let's imagine we have something which is traveling at 7.2 meters per second. And we're going to say it's traveling for 1 minute. We are being asked to find the distance travelled, so find D. So we might follow wires up again. First thing, write out the equation. Speed is equal to distance over time. Next up, I insert the numbers. So I'm going to, instead of S, I'm going to write 7.2. Equal sign lines up. D, well, that's our unknown. That's what I'm trying to find. So we need a D by there. And then T, the time. Now, we always write time in seconds. It needs to match the unit on the speed that we've been given. So I need to convert this 1.0 minutes into seconds. So that will be 60 seconds. So I need to rearrange. Now, we want to try and find D on its own. So D is divided by this 60. So undo this divide by 60. I multiply both sides by 60. So that would give me D on one side, and it's going to give me 7.2 times 60 on the other side. So we've done the rearrange there. So the next stage is to evaluate it and get the equal signs to line up, and we'll find that evaluates to 4, 3, 2. Significant figures. We need to get this to a correct number of significant figures. We have a look at what we've been given in the question. S, speed, was given to 2 significant figures. The time was given to 2 significant figures. So our answer should be given to 2 significant figures. So 432 to 2 significant figures is 430. So the answer here is 430. We need to put a unit on the end. Well, we multiplied meters per second by seconds, which gave us meters. And then the final check, is it plausible? That seems plausible to me, something going 7.2 meters per second in 1 minute. Seems like it would cover 430 meters. Okay, we'll have a look at one final example. If you want to write that one down, you need to pause the video here. Okay, final example then. Let's consider something which is traveling at a speed of 9.5 meters per second, and it travels for a distance of 340 meters. And what we're trying to do is find the time it took to do that. Find T is the question. So we follow our procedure. W means write out our equation. Speed is distance over time is our equation. We insert the numbers. Instead of S, we write 9.5. Instead of D, we write 340. And time is what we've been asked to find. So we need to rearrange this to make it say T equals. A neat little procedure you can learn with this type of an equation is you can swap the number on the bottom in the denominator of the fraction up to there. So these two numbers, the 9.5 and the t, can swap. So we end up with t is equal to 340 divided by 9.5. So we've done our rearrange. So you'll need to do some evaluation. Reach to the calculator, and I've got t is equal to 35.78947.3. Now, this is everything that's shown on the calculator display, and this is not really a good answer in physics. There's far too many significant figures here. It implies we know the time much better than we actually do. So this is where the significant figures bit really comes in. We need to get this rounded to a sensible number of significant figures. So 9.5 is given to two significant figures. 340 could be up to three significant figures. So we pick the smallest. We pick two significant figures of 9.5. So we'll round this to two significant figures. So that seems like it should be 36 to me, two significant figures. We need some units. Well, time here is going to be in seconds. So we've divided something in meters by something in meters per second. And we just check, is that plausible? And yes, I think that seems plausible to me.